Great, it's a pleasure to speak with you again. And I got to say, I'm kind of a little starstruck here. I didn't know that Representative Boone wrote the Oregon Resilience Plan. I'm very familiar with it, so familiar with it, in fact, that I've stolen some images from it. They're on my presentation, so let's just not have any issues about copyright here, okay? Right, exactly. No, that's awesome. We know several people that worked on that together. Okay, so today the title of my talk is Resilience is the New Sustainability. You'll see where I kind of go with that as we walk through the conversation. One of the things when I was introduced this morning by Bill Larson, one of the things he mentioned was this issue of what is resilience and how does that differ from what we're familiar with when we think of sustainability and green design. The issue, as he said, really kind of came to the fore after Superstorm Sandy. There were more LEED certified buildings in that area of the country than anywhere else in the world. And yes, they were built with the great goals of using less energy, of using more recyclable materials, but they weren't built with the thought of resilience to the natural environment in mind. And when Superstorm Sandy hit, it caused billions of dollars worth of damage. Hundreds of thousands of people were displaced. And one of the things I always point out is the bottom line there. It says over 10 million cubic yards of debris were generated. Okay, so this was building waste, essentially, that had to be moved off-site, trucked off-site, which cost a lot of energy to do. It had to be stored in a landfill so that it could degrade, sending toxic chemicals into the air. And eventually it had to be replaced with 10 million cubic yards of new construction. And so when we think about sustainability, we have to ask ourselves how much environmental impact did all of that demolition, all of that decomposition, and all of that replacement of materials cost the environment. If we had instead built buildings, they had built buildings that had performed better in that event, that cost would have been saved. Building something twice often is more expensive than building it once, even if you're saving a lot of money the first time. So it's not showing up here, but that's okay. All right, so when we think about trends towards resilience, I like to show this graph. This is a graph of New Orleans and of Nashville, Tennessee. And the purpose behind this graph is to show you that from 2002 to 2005, both cities were doing very well. They were both growing economically on an upward trend. Both were going quite well. And then what happened in 2005? Hurricane Katrina hit, right? And of course, it affected New Orleans. It didn't affect Nashville. And New Orleans suffered an immediate huge hit in terms of economic and property loss, about $80 billion. And, some loss, some impact was obviously to be expected. But the big story really is how long it has taken for New Orleans to start to recover. In this graph, even 7 years later, New Orleans hasn't reached the level of economic output that it did before the hurricane. Whereas Nashville, which of course wasn't affected, continued to grow and thrive and improve over time. And my point is actually not to compare Nashville with New Orleans. My point is to compare New Orleans with what New Orleans might have looked like had it been more resilient, had it been able to withstand and recover more quickly from the hurricane. And you can see that there's probably something on the order of $100 billion or more sort of left on the table, if you will, that New Orleans lost just in the intervening 7 years after the hurricane, not to mention up until today, 5 years later, because it wasn't resilient. And so this is the kind of thing that cities or companies need to look at when they're looking at planning for why resilience is important, why it is important to be thinking long-term about resilient strategies. And so what that has done, Hurricane Katrina was really the impetus for many cities and states to start to develop their own emergency long-term resilience plans, including the state of Oregon in its Oregon Resilience Plan, cities of San Francisco, New York, Los Angeles, and they basically said, we don't want to be the next New Orleans. You know, we want to put a plan into place that might take 10 or 20 or 30 years to implement, but at the end of that plan, our city, our community, our state will be much more resilient to the effects of whatever our natural disaster is going to be, whether it's an earthquake or a flood or a hurricane. Okay, so in some ways we have Northridge earthquake, and we have devastation like Hurricane Katrina and Superstorm Sandy that led to the creation of these resilience documents. So one of the things that is important to understand when it comes to infrastructure resilience, and by infrastructure, I'm focusing on buildings, but the same thing really applies to other types of transportation infrastructure, utility infrastructure, power infrastructure, water, telecommunications, is trying to understand what it is that the building code gets us. We talk about the building code, we talk about wanting to build buildings to the building code, but the building code is really a life safety document. When you look at this building, this is a concrete building, an older concrete building, probably built in the 50s, that was subject to an earthquake. You have to ask yourself, is this building code compliant? And you look at all the damage that was caused there, that building is probably a total loss. It probably has to be torn down. But it didn't collapse, and people were able to get out of that building after the earthquake. And so it actually indeed met the intent of the building code, which was to allow people to get out and exit the building safely. But the building's a total loss. And we saw that in more stark relief during the Christchurch earthquakes in New Zealand back in 2010, 2011. Christchurch, New Zealand was hit with what it considers sort of the big ones, okay? The largest events that would be expected to hit New Zealand happened at the end of 2010, 2011. And the good news was that of the thousands of buildings in the downtown area, only 2 of them collapsed. And most of the people that were killed in that earthquake were in those 2 buildings, all right? And so the question, unfortunately, though, even though only 2 buildings collapsed, more than half the buildings in the downtown area were eventually demolished because they were heavily damaged, and economically it didn't make sense to repair them. So they were torn down. And now, even years later, the downtown area of Christchurch is, it was a ghost town after the event, and it certainly hasn't recovered yet. Thousands of people were displaced, businesses were shuttered, people had to move out of their homes. And so the question comes up, was this a success story or not? And this is where there's a miscommunication, a misunderstanding of how buildings perform in earthquakes. From the engineer's perspective, like myself, only having 2 buildings collapse out of thousands in the downtown area was clearly a success. It means that almost every building there performed the way the code expected it to perform in its sort of worst-case event. But from the perspective of all those people that were made homeless or lost their businesses or lost the most important asset they have or the most important investment they have, it was a complete disaster, right? A complete catastrophe. And so what the U.S. Resiliency Council's job is, what our mission is to bridge that gap of misunderstanding. Show people how buildings perform in earthquakes, but also help them understand how they can improve that performance to make them more resilient, to meet the public's expectations of how our infrastructure should perform. So when we talk about modern codes, we're really talking actually, even then, even though these are life safety documents, about a fairly small subset of buildings in most metropolitan cities. I mentioned this morning. The cities of Seattle and Portland, but the same is true for San Francisco, Oakland, Los Angeles, probably most metropolitan cities, I'm sure Vancouver is the same way, is that 90% or more of buildings were actually built before modern codes. If we consider modern earthquake codes anyways to be, developed sometime in the mid-1990s, most of the buildings in these cities were built before then. So if we're talking about modern codes being life safety documents, and 90% of the buildings in these cities being built before even those modern codes, the risk we face is obviously very significant, not only to property damage and loss of business opportunities and economic output, but to safety itself. And so here's what I'm stealing from your plan, is if we look at Oregon here, and we look at when building codes were developed. I wonder if I can take this. No, I probably can't, but let me just go here. So you can see that the first modern seismic codes in Oregon, is it the circle? Oh, perfect, okay. The first modern codes in Oregon were developed in the mid-1990s, as with most states for earthquakes. But here is the population of buildings by their age group. And you can see that even when it comes to schools, fire police, universities, important buildings where we have lots of people, lots of young kids, or critical to emergency response, the vast majority were built well before the onset of modern codes, okay? And, when we talk about police and fire, these are going to be our first responders. These are going to be the folks that are going to be tasked with getting out there and making sure everybody else is safe. And if they're in buildings that were built 50 years ago, and obviously our children are in schools now that need to be improved. So again, another slide from the plan. This is what the expected toll of an earthquake, a Cascadia subduction zone earthquake, is likely to have just on the state of Oregon, not to mention Washington and British Columbia. And again, as I said this morning, it's a matter of when, not if, right? The last significant event was back in the 1700s. The return period for this type of event is on the order of 300 or so years. So as you can see, we've kind of burned through our borrowed time, and now it's sort of, I think there's a 1 in 3 chance in the next 50 years that event will happen. And this is the kind of economic and social impact we can expect. And this affects not just the areas of the state on the western side, but obviously this is going to have a massive impact on the entire state, right? The state is going to have to marshal all its resources to recover, because of course we know the federal government isn't going to come in and solve the state's problems. It will help, but the state is going to have a massive burden to recover, and that's going to affect everybody from the west coast to the eastern edge of the state. So what is the purpose of the U.S. Resiliency Council? Well, there's a lot of ways to measure resilience. There's a lot of aspects of a community that contribute to resilience, from again, the functioning of our schools, the functioning of our businesses, emergency response, shelter, access to food. All of these things are important to a community, but one thing is sort of central, is that all of these things are done somehow in buildings. We live, we work, we conduct business in buildings, and so central to the resilience of our communities is the performance of our buildings. So the USRC was started back in 2011 with the mission of educating the public about how buildings perform in earthquakes and eventually other hazards. We're working now on a wildfire system, as well as wind and eventually flood. And to be able to show through a rating system, similar to the way the U.S. Green Building Council works with its LEED rating system, to be able to show in quantifiable terms how we can measure performance. Now, there have been a number of studies released by FEMA over the past decade about the benefits of mitigation. And, I talked about this morning as well, that it's often hard to make the case to invest today in retrofitting buildings or designing to higher codes, because there's certainly a short-term cost to that, right? But the benefits in the long term are profound, and they're measurable. An investment today in seismically better performing buildings will reduce losses, will reduce damage, will reduce deaths in the future. And again, as I said this morning, if we have a when, not if mentality, we're focusing not just on our own needs today, but on the needs of future generations. We're making them more self-reliant. If today we make relatively small investments versus the very large investments that will have to be made in the future when the event happens. So the USRC, the U.S. Resiliency Council, is based around a rating system for buildings and earthquakes, and as I said, we're working on a rating system for other hazards now, that focus on the three most important aspects of how a building performs. Safety, of course, the most important, wanting to make sure that people can get out of a building, the building won't collapse on them, but also important, damage and recovery. These are things that are often not talked about in building codes. As you can see here, codes are generally focused on safety, on allowing people to get out of a building, making sure it doesn't collapse. But when we talk about resilience-based design, we really have to be talking about these other two dimensions as well, because that forms the economic and social fabric of our communities, our companies, and I always bring it back even to our families. You know, whether this is a $50 million convention center or a $250,000 house, the impacts are felt whether you're a family or a big corporation. And what the USRC tries to get across, and I'll show a couple of examples of this, is that it doesn't take an enormous investment to make buildings perform better. I gave you that analogy this morning of the Corvette. The idea that it costs between 0 and 5% typically for a new building to make its design resilient so that its investment will be protected, damage will be limited, and it can recover more quickly, is something that a lot of people don't understand, but starts to make a lot of obvious sense when you're planning a new development for the long term. So I'm going to give you an example of how that works. And I'm certainly not meaning to single out any type of construction here. This is just an example that's sort of well known in the popular literature. Any of you that live in Seattle probably know about the Bullitt Center. It was built several years ago, and it was built a multi-story building built out of wood. And it was considered to be, by the developers of the building, the greenest building in the world when it was built. That greenest commercial building in the world is taken from the developer's website. And all of these quotes actually are. They said the building had a 250-year lifespan. It has net zero energy, net positive energy. It has self-composting toilets, It really is completely self-sustaining during regular operations. But the building's also built out of a structural system, a lateral system, down here at the bottom where you can see, made of older style steel bracing. Okay? These are kind of steel braces that can perform well in small or moderate earthquakes, but in larger earthquakes have been shown to have real issues. I'm only going to show you two graphs. I'm not going to really even explain the graphs to you today, only to say that when subject to large ground motion, like you would get from a Cascadia subduction zone event, those types of braces can buckle and tear and fracture. And when that happens, the building suffers a lot of permanent drift. So after a large earthquake, the building can be tilted to the point where it may not be repairable and may have to be torn down. And so that makes a building that is sustainable day to day something that isn't very sustainable when you consider the inevitable earthquake and if it has to be replaced. Other types of materials, and certainly you can build resilient buildings out of any material, wood, steel, concrete. But one example that I show is ductile concrete. Okay? When we build buildings today out of concrete, we use a lot of reinforcing steel. Those buildings are very ductile. They're able to accommodate motion back and forth without this sort of catastrophic failure or yielding. And what that results is in better performance, more resilient performance. And I show that through this, again, I'm just going to show a few graphs. This one I will explain. This one shows the amount of damage to a building here, repair cost as a function of how much it costs to build the building. So 100% would be full replacement cost of the building. And the horizontal graph represents the return period of the event. So by return period, you've all heard of a 100-year flood or a 500-year flood. Well, we do the same things with earthquakes. A 100-year earthquake is smaller than a 500-year earthquake. And when we design a building to code, we're typically designing for about a 500-year earthquake, right about here. And as you can see, a building that is built that may not have resilient features in it can suffer, even though both of these buildings will be safe and you'll be able to exit both of these buildings. One might suffer so much damage that it ultimately has to be replaced, while another might suffer relatively minimal damage that it can be occupied during repairs and business can resume as usual fairly quickly. And the USRC rating system then will rate those buildings according to how they perform, so that if you're looking to build a building, or you're looking to buy a building, or lease a building, or insure a building, or lend on a building, you can start to make decisions that are based not only on the safety, but on the investment quality of that building. So let me show you a couple of case studies of how the USRC is working with its partners, both cities and private owners, to make buildings more resilient. This is a 4-story building in Roseville, California, which is just outside Sacramento. Okay, so the seismicity isn't really large, but it's still, decent given that we're in California and everywhere in California has earthquake issues. It's a 4-story building. It's a civic building. It's meant as a city hall annex and community college space. And it was, the city planners said, look, you just have to design this building for code, okay? We don't want anything more than code because we can't pay for it. Well, the engineer and the contractor, Clark Pacific, took an approach that, okay, fine, we'll design your building to code, but we're going to use a structural system that's smart. We're going to be smart engineers and smart contractors, and we're going to meet your cost requirements, but we're going to do it by choosing the structural system and working with the architect to design the building in a way that it'll perform better. And in fact, it ended up being the building to receive the first USRC Platinum rating. Platinum rating, 5 stars across the board, which basically means the building will not only be safe, but damage will be on the order of 5% or less than the replacement cost of the building. You think of that, that's less than the deductible on an insurance policy. And the building will be operable literally within hours or days after the event, because the damage will be so minimal. And this was done at a cost, again, this is a city project, right? So they didn't have, it wasn't an Apple, headquarters where they're spending unlimited amounts of money. This was a city project. It met the code. It met their cost and schedule requirements. But because it was done in a smart way, it was very resilient. Here's another example of a building that's being constructed right now. We talk a lot about affordable housing, okay? Affordable housing is one of the key chronic stresses that I mentioned this morning in most major cities. San Francisco absolutely among them, and this is a project going up in San Francisco now. It's a 6-story affordable housing complex for seniors. And about 20% of the seniors that will occupy this housing were formerly homeless, so really low income. So this was done through a sort of a city grant program to a developer, and there really was, again, no extra money available for this project. But similarly to the other building I showed you, the engineer thought about the design, thought about developing this building that had a unique foundation system that put shock absorbers in the foundation of the building and built concrete walls up from there. This building would normally have been constructed today out of timber, maybe with a 1-story podium of concrete parking. But the engineer was able to devise a system built out of concrete that didn't cost any more than the budget, that would be completed on time, and also will achieve a very high USRC rating, because just as the function of these shock absorbers to limit the amount of permanent drift that the building suffers. So here you have a case where you have something that is addressing affordable housing now, today, but when that inevitable 1906 repeat earthquake hits, this building will be there for those, maybe not the same occupants as originally moved in there, but it will be there for the low-income occupants 20 years from now, or 30 years from now, or 50 years from now, or whenever that earthquake hits. And that's the best thing about making these investments, is it's a prudent, long-term economic decision. You're protecting a chronic stress. You're addressing a chronic stress, the affordable housing today, but you're also addressing that acute shock that might not occur for 50 years, all right, and the people that will be affected then. So, what we like to do with the USRC is work with cities especially. Cities really led the way when it came to the USGBC and green development and requiring city-owned buildings to be more green, more sustainable, using that older term. We want to do the same thing. We're doing the same thing with cities now. We hope to be able to partner with many of you, actually, that are looking to, grow your cities in a resilient way. I really enjoyed the talk today by the mayor of this city. I'll just take a minute to just describe a really short story. When he talked about building basically this big underground sewer storage tank, I mean, how unsexy is that, right? And it brought me back, and honestly, it made me a little emotional. It brought me back to this time when I was in college. I was a civil engineering student. I was majoring in structural engineering, and I went with my church down to Mexico, this little orphanage in Baja, Mexico. And our job was to build a septic tank, okay, for these kids down there in this orphanage. And so we spent the whole week basically pouring this slab for this giant S-hole, literally, a hole that eventually would be filled with stuff that you'd never want to see this thing again, to be covered up, and nobody would, cut a ribbon for it or make a big presentation. But, it was one of the most beautiful things I ever did, because I knew the impact it was going to have on these kids. And so when the mayor of Spokane spoke about this sewage storage thing that they were building, I said, that's the kind of forward thinking, that's the kind of selfless thinking that great leadership is all about. So, we want to be able to work with leaders like that, with cities, to help them plan for the future, to show them that they can build buildings that go beyond the code for just a sliver more cost and get something that will be there for the long term. So how does this work more broadly when it comes to a community? So once you start developing community guidelines for improving building performance, you start to develop a strategy that makes your whole community more resilient. I showed you that slide earlier, that how buildings are central to all of the other aspects of a community that make it resilient. You start laying out guidelines for how new buildings should be built or existing buildings should be retrofitted, and you can start to see where your needs are and where you're succeeding. Okay, so you can look at your housing in your city, or your food distribution. People talk about, grocery stores are built all the time. They're very simple buildings, but how important they are to a function of a city. Your schools, you can start to look over time, over the next 10, 20, 30 years, how your city is going to improve and get to, the desired threshold of performance. Not every building has to perform perfectly, but you have to have enough housing and food and schools and emergency services, etc., to be able to allow your community to recover. So that's what the USRC is trying to do in working with communities. So one of the other things that we're doing is, I'm not sure if this is going to work, and you saw this if you were at the drone session yesterday, is we're working with emergency managers to help them plan for disasters, because as I said this morning, you cannot avoid all your disasters. You cannot spend your way out of the impact of disasters. They're going to hit you. You're going to have to deal with them in some degree. And so, let me just see if this, yeah, okay. So what the USRC is doing is working with one of its partners to map cities, digitally map cities, so that we can identify specific buildings. There are certain cities, like the city of Seattle, that have very good databases of their building properties, okay? But most cities don't. And so by using aerial mapping technology, we can actually identify individual buildings and the properties of buildings, how tall they are, what kind of materials they are likely made out of based on the facade system, whether they have certain kinds of irregularities that might cause them to perform poorly in earthquakes or in floods or in hurricanes. And by doing this, we're able to give cities the information that they can start with, a foundation that they can start with to make decisions about how to improve the performance of these buildings. So we're actually doing a case study on the city of Seattle, again, because it has so much good information about its buildings. And we are looking at the unreinforced masonry buildings in the city. There are a lot of them. There are thousands of them. City of Seattle has been quite slow in actually implementing retrofit ordinances for its URMs. But what we can do is we can look at the current state of nature, if you will. If that Cascadia subduction zone event hits, or another repeat of the Nisqually earthquake, or a larger event, we could estimate now with the tools we have the number of the amount of damage that will be caused, the number of casualties that are likely to occur based on building collapse, and the amount of time that the buildings will be out of operation with that earthquake. And then we can look at what would be the case if we implemented a retrofit ordinance that required all the URMs to be retrofitted to reach some level, say a USRC certified level of performance, a minimum life safety level of performance. And we can see how that reduces the expected loss or expected downtime. That downtime can be converted to economic output for the city. This cost can be converted to how much the federal government or the state government will have to come in and help the city of Seattle recover. And if we can reduce that through a retrofit ordinance today, then, that's less that we will have to be reliant upon others, or the city of Seattle will have to be reliant upon others after an earthquake happens. We can also look at things like injury concentrations, or shelter needs, or debris concentrations. And we can do this in real time once the earthquake happens. So we can do this as part of planning if there's an earthquake. But using U.S. Geological Survey data that comes out immediately after an earthquake happens, once an earthquake happens, city emergency responders can get immediate information on where the hot spots are likely to be. Okay, where they're likely to have to send emergency vehicles to help injured people, where crews are going to have to go to remove debris, where shelter locations are likely to be needed because housing will have been destroyed. So this is a kind of emergency response tool that can be used as well as for the planning purposes. One example of this is, again, this goes back to sort of the digital platform, this is an earthquake and landslide that happened in Italy. And this is a 3D digital model taken by a drone or aerial vehicle of this little township that was damaged in the earthquake. And what this does is it actually digitizes this aerial image. So now just what you see in photographs becomes actual representations of the buildings. Okay, you can see where buildings have been damaged. You can see where debris is generated and how much debris was generated. And those little animations that you saw there were measuring the width of roads. All right, why is that important? Well, if debris has fallen into a road, that road isn't going to be accessible to emergency vehicles. So in a large city where you have to coordinate transportation and emergency response, being able to automatically determine what transportation routes will be passable is an important thing. So this is one way that the U.S. Resiliency Council is working with its own members and with cities and local governments to develop tools that they can use not only in the planning, in the preparedness, in the response, and the recovery. That's what resilience is all about. Again, as I mentioned this morning, those three items of avoid, assign, and adapt are sort of representations of different times within the resilience cycle that you use these different tools. For planning and development of new building codes, for preparedness and training of your response personnel, and then for actual response and recovery after the event. Okay? So our ultimate goal really is not to supplant this idea that green and sustainable design is important. It obviously is. We want to reduce the impacts that we have on our environment so that environment is enjoyable and usable for our next generations as well. But really, true sustainability, resilience, and green design go hand in hand. So we're working with the U.S. Green Buildings Council to incorporate the USRC resilience system into its overall sustainability metrics, recognizing that it's a combination of both that really will make a community or a company or your own family sustainable and resilient in the long term. So, I would love to be able to meet with every one of you and talk about what your needs are as city and government leaders or business leaders. But I hope to be able to talk with you on the phone, an email, come visit, and learn how we can partner with you as a nonprofit to help make your organizations more resilient. I have out at the table the Pacific Northwest Building Resilience Coalition table. There's a little document on the USRC, and I have some thumb drives which have a whole bunch of more information about the U.S. Resiliency Council, including my contact information. But you can reach out to us. We'd love to have you as partners, as members of the USRC, and we'd love to help make you all more resilient. Thanks.